The story begins in 1839 when a 19-year-old French physicist, Alexander Edmond Becquerel, discovered something extraordinary. He noticed that when light struck certain materials, it produced an electric current. He called it the photovoltaic effect. Nobody thought much of it at the time, but that's really where the story began. Fast forward to 1883. American inventor Charles Fritz built the very first solar cell by coating selenium with a thin layer of gold. It worked, but barely. It was less than 1% efficient, and it generated electricity, but nowhere near enough to power much of anything. Still, it proved the principle that sunlight could be captured and turned into usable energy. And here's the twist. The science was sound, but for years nobody could figure out how to make it practical. That would take Einstein and a space race. In 1905, Albert Einstein explained the photoelectric effect, how light is made of particles called photons, and how those photons can knock electrons loose from matter, essentially creating a flow of electricity. His explanation gave solar energy a rock-solid scientific foundation. In fact, it earned him the Nobel Prize in physics. But physics on paper wasn't enough. Solar needed engineering. That breakthrough arrived in 1954 at Bell Labs when scientists created the first practical silicon solar cell. Efficiency jumped to about 6%, and for the first time in history, a solar panel could actually power devices. And then, in 1958, the US launched Vanguard 1, the first satellite powered by solar panels. At the time, most satellites ran on chemical batteries, which only lasted a few days or weeks. Vanguard 1, however, thanks to its solar cells, stayed alive for over 6 years in orbit. That success changed everything. After Vanguard, NASA and other space agencies quickly shifted. By the 1960s, virtually all satellites were designed with solar panels as the primary power source. Unlike batteries that drained fast, solar provided continuous renewable energy in orbit. The technology proved so reliable that it became the energy of choice for spacecraft, a role it still plays today. But back on Earth, adoption was slower. Solar panels were expensive and inefficient. Do you love uncovering the hidden side of everyday life? That's exactly what this channel is about. Subscribe and join me every single week for another random deep dive. In the 1970s, the oil crisis hit. Fuel prices skyrocketed, and suddenly governments and scientists had to take renewable energy seriously. Solar power, which was limitless and clean, looked like a real solution. Funding and research poured in from there. As the years went on, solar panels became cheaper, smarter, and more efficient. Governments stepped in with incentives, homeowners started selling power back to the grid, and factories began mass production. Bit by bit, what was once an experiment transformed into an essential part of how we power the world. Today, solar generates over 1 trillion kilowatt hours of electricity worldwide each year. It powers homes, businesses, and yes, still satellites. Have you got a topic you'd like me to cover? Leave it in the comments below and it might just become the next video.